Hey guys, so Jeff Clark here, of course, and we're going to take a look at trigonometry. And our first section is going to be an introduction to trigonometry in terms of sections. And the current textbook is 4.1, but it's introduction to some concepts in trigonometry. Let me show you the screen and how we're going to get started here. So as you can see here, there's some vocabulary we're going to be looking at. That will include things like angles. Of course, trigonometry has a relationship with geometry. Angles, algebra and geometry, you've seen complementary angles. We'll go over that again. And supplementary angles as well. Two angles that add up to 90 degrees is they're said to be complementary. And supplementary, the angles add up to 180. Obtuse angles, acute angles, angles that have a terminal side, and then an initial side will also have those. Things that are called reference angles, and some other things as well. In algebra, our variables tend to be like x, y, and z are kind of the most commonly used. In trigonometry, we usually honor, in some cases, we honor the Greeks with their letters. Now they have uppercase and lowercase letters of their alphabet. Some of these are probably very familiar, I'm sure it is. When you say alpha and beta, those are very commonly heard variables. If you go all the way down here to right here, I'll zoom in too so you can see what I'm doing here. Yep, that's pi. That's the one you're commonly seeing for the number, but that is a letter of the alphabet. Uppercase pi is a symbol, symbol used in calculus courses to mean something as well. So if you move on to calculus sequence, you'll see pi. Some other letters too, like this one here, sigma, uppercase sigma, that's summation notation, we use that. And that symbol, that's a lowercase sigma, is used in statistics and it means something. Probably the common ones that we use, or our author will use, sometimes he uses phi, that lowercase one. Sometimes theta is a very famous one. That's very common, theta. And then alpha and beta, I would say, are the next ones down the line. So along the way, you'll see some of those Greek letters of the alphabet. All right, so to get started, we're going to take a look at, it looks like the XY axis where you've got quadrants. And the upper right corner is still quadrant 1, like in algebra or in advanced math, pre-calculus. Quadrant 2, 3, and 4. So it goes counterclockwise. So just like what you would expect, and that's a good thing. Turns out that when you look at rotations around, we've got two different directions you can go, either clockwise or counterclockwise. In measuring angles, to measure them positive, you're going to go counterclockwise, and to measure them as a negative angle, you're going to go clockwise. So for instance, here's your XY axis. We always start on the positive x-axis when we indicate the look of an angle in standard position, they call it. An angle in standard positions always start at the positive x-axis. So when I draw 90 degrees, even though that 90 degrees looks like it's down here as well as in quadrant 4, I always, in our course, start with a positive x-axis and draw it. Since it's positive, we're going to draw it this way, and you put a little arrow. The beginning starts right at the positive x-axis, standard size. The terminal side is right there at the positive y-axis, and you put your arrow there so it indicates the direction that you're going, which is counterclockwise. So to do negative 180, you always start at the positive x-axis, but we're going to go this direction here. That's negative 180. Negative 270, so there's negative 90, another negative 90, and a third negative 90. So that's negative 270. And again, going clockwise means it's negative. And then 360 all the way around and stop. Now there's two types of angle measurements. One's called degrees, which is probably more familiar to you guys. And there's a little degree marker like down here, a little degree marker we typically use instead of using the word degree. And there's another measurement called radians, degree radians. Now in your calculator, there's also a place where it's degree radians. Let's see, where would I want to show you? Angles. Let's take a look and see what angle talks about right here. So if I go second here, okay, there's a little degree marker that if it was necessary to use, that's what I would do. I'm personally never going to use the little degree marker. What I'm going to do is go into mode to what they call change the mode if I need to, and there is a degree choice or a radian choice. So it depends on what you're evaluating, what you're using. If you're using degrees, you want to make sure you're in degree mode. Right now I'm in this thing called radian mode. And on occasion you guys will forget to check. So you might write yourself a note, put it on a flashcard and say, every time I start my homework, I want to check the mode I'm in and check the problems that I'm supposed to work. If you're working with degrees, you got to make sure you're in degree mode. So 180 degrees. All right, that's positive. You know that 180 degrees would look like this. That's 180 degrees. There is a radian measurement that is equivalent to 180 degrees. And there's a little conversion formula if you wanted to memorize this. So if I want to convert 180 degrees into radians, there's this ratio of pi is to 180 degrees. Those are equivalent. So that's a radian, that's a degree. If I multiplied 180 degrees times this ratio, notice 180 degrees go away and you get pi. 180 degrees is equivalent to pi. 90 degrees the degree markers cancel. 90 goes into 180 twice. So 90 degrees is equivalent to pi divided by 2. Pi divided by 2. And if you're going to do a angle measurement, so instead of 90 degrees, you'd still go here and you'd stop, but that would be pi divided by 2 as a radian, 120 degrees, you go 120 degrees. Again, pi divided by 180. You'd say, okay, they don't cancel, but certainly 60 goes into both. 60 divides into 120. Let's see, 2 times. 60 goes in here, 3. So the result looks like it's 2 pi over 3 radians. 2 pi over 3 radians. If you're going to look at 120 degrees measurement, this would be 90 plus another 30, kind of lands you right about there. This is called the terminal side. And this is the initial side. So the radian measurement is in the same position as this. So right about there, measurement, that's 2 pi divided by 3. 2 pi divided by 3. All right, to be negative 135 degrees. Okay, negative goes clockwise. So that's negative 90. And I need, let's see, what, 45 more from 90 gets me to 135. So 45 stops right about, well, stops right there in halfway, right there in the middle of the quadrant. That's negative 135 degrees. The radian measurement would still be in the same position, but it would be called well, let's see. 5 goes into it for sure. Anything other than, let's start with 5. 135 divided by 5. Okay, let's try that. 135 divided by 5. Okay, 27. So 27 here. 180 divided by 5. 36. Oh, I recognize 9 goes into both of them. So 9 into this is 3, 9 into this is 4. So it feels like negative 3 pi over 4 is the radian measurement, which is true. Think about this. If I looked at the quadrant this way, there's 1/4. Okay, this is 45 degrees because it's half of 90. So that's a quarter. That's a quarter because this is a half. So I'll do it this way. This is pi over 2. Remember pi over 2? Each one of these are pi's over 2. That's a pi over 2. That's a pi over 2. So if this is a pi over 2, each one of these is pi over 4s. So this is a pi over 4, and that's a pi over 4, and so on. If I wanted 3 pi's of the 4s, there's 1, here's 1, here's 2 of them, there's 3 of them, and it's negative, so it's going to go this direction, negative 3 pi over 4. And finally, negative 300 degrees, and make that into a radian, pi over 180. Let's see, 60 goes into both of those. That would be 5 times. 60 goes back into this one. Oh, this is 3 times. Oh, it looks like negative 5 pi over 3. That's what's called converting degrees into radians. You can go the other way as well. If you want to convert radians into degrees, you flip that fraction that we had used, that ratio, and that'll take your radian and turn it into a degree. Just like this, pi over 2 is equivalent to 90 degrees, because if you multiply by this ratio, the pi's go away, and 2 goes into 180, 90, the little degree marker is still there. Okay, pi over 4. Again, 180 degrees divided by pi. Okay, pi's go away. 4 goes into 180. Well, let's find out. 180 divided by 4, 45. So that would be 45 left over. So what's left is 45 degrees. Take this radian, which is negative 5 pi over 3, put the pi down here to make that go away, 180 degrees up here. And again, pi's 3 into 180, 60 times. So -5, that's -300 degrees. And finally, now here's the thing. If you write down a number and you write it down without a little degree circle, I am going to interpret that as a radian. There's no degree on that. 6 degrees is not the same as 6 radians. It's not. So if I just write the number 6, it's a radian. Now, it doesn't have to have a pi involved. It just has to be what's called a radian. Pi, by the way, is 3.1428 and about. So if you said pi radians, rads, that's around 3.1428 rads or radians. What I'm saying is you don't have to write the word rad or the phrase rads. Just writing 3.1428 is good enough to indicate to me and anybody else who's looking at it that it's a radian and not a degree. If you intended this to be a degree, you would have to say 3.1428 degrees and then do your measurement. So for 6 radians, I'm going to take the 6, there's no pi involved here, and then multiply it by 180 degrees divided by pi. Now, there's no canceling because this isn't pi. So the only thing you can do is multiply all of this together and get a squiggle squiggle decimal approximation, and it's still a degree. So I would go 6 times 180 and then divide that by pi. So divide that by pi and you get a decimal. So that's degrees. It's a round squiggle squiggle 343.8 degrees if I did it to the tenths place. Okay, next page. A little review about complementary and supplementary angles. Talks about it up there. So if I look at this angle, 81 degrees, to find its complement, I need a number that gives me combined 90 degrees. I need a number here, so I add it to 81 and it gives me 90. And I think you guys can do that in your head. 9 plus 81 is 90. Same thing over here, a supplement gives you 180. So what you could do is say, on the complement, say I have 90 or I need 90 and I subtract what that was given to me, 81, and so I get the 9. Okay, same thing here, supplement. I need 180, I subtract 81, so I need 99. 99. Now, if I just left it 99, that's a radian. Now, you're talking degrees, so you have to put a degree marker there. Okay, pi over 6. Now that's a radian and that's a radian. Pi over 6. What you have to do is instead of equaling degrees, equivalent would be pi over 2, and equivalent would be pi. So a little bit more challenging, you just can't do this in your head. To get the complement here, the complement, C for complement, you take the pi over 2 and subtract pi over 6, and that gets you the result of the complement. The complement is the difference of what you want all together, which is pi over 2, and what you were given. A common denominator, that would be 6. So if you multiply top and bottom by 3, so it looks like you get 3 minus 1. So 2 over 6 with the pi, which is 1 pi over 3. So pi over 3. Pi over 3 is the complement. And the supplement, capital S for supplement, you take the pi, the whole, you take the whole, and you subtract off what you're given. And the same thing, you want to do like a common denominator. So you're going to go, let's see, put a 6 here and a 6 there. So you get 6 pi minus pi over 6. You get, 5 pi over 6. Since that's a decimal, since that's a decimal, then what I'm going to do is I'm going to take the decimal equivalent of the complement. So the decimal equivalent of pi over 2 is what I meant to say. The decimal equivalent. Let's see. Try that again. Second pi divided by 2. Okay, and then I'm going to subtract what I was given, which is 1.2. And I didn't subtract it, my mistake. Let's try that again. Second pi divided by 2. And then I'll subtract 1.2. Okay, there you go. 0.37. Let's say it's one decimal place. Since I have it there, I might as well do one decimal place. So it's approximate 0.4. And to do the same thing, if I want the supplement, I'm going to take pi equivalent. I'll subtract off the 1.2, and I get about 1.9. A few of the things that are commonly known, right angles are 90 degrees. Acute angles are less than 90 degrees. Got to be positive though. Obtuse angles are angles that are bigger than 90 degrees, less than 180, or an angle between these two radian measurements. And then an arc length, the whole idea about an arc length. If I have a piece of pie, let's say it's a pizza, and you got a wedge like this, and this is your pizza. The arc length, which is located as the letter C, this is the arc length. It's like the crust. It's like the distance, the length of the crust. That's called the arc length. And you have to remember that theta, in this case, theta must always be in radians to make sense. There'll be some problems that will be given to you on the homework, I'm sure, that'll say, find the arc length. And they give you the radius, which this is the radius r. And they say, give you the angle, which this angle right here would be theta. And they give it to you in degrees. But you got to remember to convert the degrees to radians to get the actual length of the arc. So be careful of that. Okay, quadrants location. So this is the thing that you are going to try to do, and radians are kind of hard. So here's an idea. If you convert this to a degree, it might be easier to identify the quadrant. And that's positive, so it's going to go in a counterclockwise direction. Let's do that. Let's take 5 pi over 3 and turn it into a degree. So put a pi down there to get rid of it. And then the 180 degrees up here. So the pi's go away. And the 3 goes into this 60 times. Multiply straight across, it looks like we get 300 degrees. Now, to figure out where 300 degrees is, I'm going to give you, on a previous page in the packet, I call it the wheel. Okay, so go to a previous page in the packet right here. I'm giving you a copy of the wheel. And it's nice because it gives you not only the degrees, it gives you radians. So if I'm looking at 300 degrees, there it is right there, that's positive. There's also 5 pi over 3, the equivalent. The 5 pi over 3 right here. Yeah, so that's in quadrant number 4. Quadrant number 4. So this is 1. This is quadrant 1, this is quadrant 2, this is quadrant 3, and this is quadrant 4. So quadrant number 4. Now with, let's do this one. That's easier, 163 degrees. If you go 163 degrees, well, it's got to be over here. There's 150, 163 is sitting over here. So quadrant number 2. Let me do this one next, and I'll come back to the negative. 4.6 radians. Now, where does that lie? Well, that's not easy when your radians are these old pi things here. But pi is just a number. It's 3.1428. So if I wanted the decimal approximation of this, I just take pi divided by 3. If I took pi divided by 3, yeah, it's about a little bit more than 1. I want a decimal, according to this, I want a decimal that is 4.6. I'd like to know where 4.6 sits here. Well, gosh, let's see. Let's try 3 pi over 2. Let's see what the decimal answer to 3 pi over 2 is. 4.7. Well, I wanted 4.6. I think it was 4.6. Yeah, 4.6. Well, that's too far. 4.7 is too, probably 4.6 is somewhere over here. So quadrant number 3. Well, what about that, Jeff? Well, that's 3.14. 4.6 has got to be over here. So quadrant number 3. Now, if I did this in degrees, it might be easier rather than the radians. So let's try this again. Let's do it in degrees. Negative 5 pi over 12. Put the pi down here. 180 up here. And you know pi is going to go away. I'll just use my calculator now and multiply 5 times 180 and divide by 12. So 75 degrees, negative 75 degrees. So the negatives go this way. These are all positive answers. Isn't this negative 90 right there? So negative 70 has to be short. So it's in quadrant 4. Negative 70 is down here, stops right about there. So this is in quadrant 4 as well. Okay, another topic is going to be angles that are coterminal. So let's see, coterminal angle is an angle, has the same initial positive axis side. So everybody has the same standard initial side. Excuse me. And it's also got the same terminal side. I'll show you an example. Find two coterminal angles for this 81 degrees. Okay, 81 degrees is sitting like right about there. 81 degrees. To be, and I'll do it in red so you can see this. To be coterminal, you just have to start at the same place and end right there. You could go this way. So it starts the same positive x-axis and ends right there at the terminal side. You just have to figure out what that is. So here's an idea. Isn't 360 all the way around? I'll say that again. 360 is all the way around, 360 degrees. 2 pi is the radian, is all the way around. 360 is all the way around. I'm going to subtract off 81 degrees from 360. I'm going to subtract 360 minus 81. Let's try that again. So 279 is this amount. but it's negative. Negative 279 degrees is a coterminal angle. This is coterminal. Negative 279. That's one example. Here's another one. 81 is still there. As long as it starts the same place right here and ends here, it's called coterminal. So I'm going to loop around this way, which is positive, and stop right there. I just looped around 360 degrees, a whole revolution, and continued with another 81 and stopped right there. So coterminal angle in this case could be 360 degrees all the way around and the 81 original. So what do I have? 441 degrees. That's a coterminal angle. You actually have infinitely many coterminal angles. Excuse me. Infinitely many. I'll do this one. And then I'll do one more. I'll do this one. 17 pi over 6. I just have to figure out where 17 pi over 6 is. 17 pi over 6. Well, we could turn it into a degree, or I can think about, let's see, 6 goes into 17 almost 3 times. I can see how many revolutions it goes around. So for instance, 17 pi over 6 is the same as 12 pi over 6 plus 5 pi over 6. 12 pi over 6 is 2 pi. 12 pi over 6 is 1 revolution all the way around. So you would go like this. That's 12 pi over 6, or 2 pi. Then I got to stop at 5 pi over 6. So I can go back to the wheel and look where 5 pi over 6 sits right here. So this one here has 12 pi over 6 of the 17, and then a little bit more gets you over here to 5 pi over 6 more. This right here is 17 pi over 6. Now I want a coterminal angle to that. You don't want to repeat it. That's not coterminal to itself. It's trivial. So here's a coterminal angle. As long as it starts at the same initial side and stops at the terminal side, that's considered coterminal. That right there is 5 pi over 6. That's 5 pi over 6. So that's one example. Another example could be start right here and go this direction, which is the leftover of 2 pi. So 2 pi is all the way around. 2 pi is all the way around. And if I subtract off the 5 pi over 6, that gets me the leftover. And that's what I'm looking for. Let's see. Common denominator, 12 pi over 6 minus 5 pi over 6 is, what, 7 pi over 6. So these would be two coterminal angles, 5 pi over 6 and 7 pi over 6, but this one has to be negative because it's going the clockwise direction. So put a negative. That looks kind of crummy. So let's go negative 7 pi over 6. So those are the two. These two right here, this one and that one, are coterminal angles. Okay, so there's two examples. I know I said I was going to do another one, but those are two examples. One's with radians, and one is with degrees. And the author does a couple more as well in your textbook. The rest of the sections here, I just want you to know, well, that's just another wheel right there. We won't be doing area of a sector, so we won't be doing that. And we won't be doing linear speed. We won't be doing that in this course. So nothing with that. So the next pages we don't do at all. So just just keep scratching those off. I think we're done, actually, is what I want. Yep. I'm all done with 4.1. I'm all done with 4.1. That should give you enough to get started and finish, hopefully, 4.1. Okay, until next time, I'll do 4.2 on the next go around. Take care.